All right, hello, this is Jacob Tucker, and in this video, I'm going to be talking about and explaining the Float smart contract. So if you don't know already, Float is a proof of participation platform on the Float blockchain, and it looks something like this. It's at floats.city. And, as you can see, there's been 3 million floats claimed, tons of events created, and, I have a bunch of floats in my collection right here. And I've created a lot of events before. So Floats is pretty popular, and I want to talk to all of you about the code behind the Float contract, and maybe you will learn something today. So what I have right now is I pulled up the Flow view source. So this is a way to read the code of a smart contract. So I'm going to zoom in a little bit, and yeah, let's dive right into it. So, spoiler alert: there's quite a few complicated elements of this. So, if you're not familiar with cadence, it's going to be quite difficult. But I'm going to try and do my best to explain to a relatively beginner cadence coder. So we start off by just declaring the float contract. It is a non-fungible token contract. So this means that the NFTs that come from float are official NFTs on the Flow blockchain. Here we simply define some paths for floats, right? So this is pretty simple. That way, anyone can know where floats are stored in the user's account. And we also have some events here. So one of the things that I like to talk about in the events list is we have this one called public event float claimed. Now, if we actually go to the live feed by clicking on this right here, this will take us to a floats.city/live, and you'll be able to hopefully, if people are claiming NFTs right now, which I believe they should be in a second, we will actually see some floats flying up through the screen. So I'm going to wait here for a second while it's doing that. But what's happening is that we have an event called Float Claimed, and this event gets emitted every time a float is claimed from this contract, and we'll see that in a bit. But the point is that this web page actually uses this event and uses Graphel to query for those events and display them on this web page. So hopefully, if I leave this here long enough, some floats will be appearing on this page. Okay, so then we have some classic non-fungible token events right here. And then we dive into the more legitimate parts of the contract. So we have a total supply, and this is just the number of floats that have been minted. This is standard for every single NFT contract, and we also have a public var total float events. So that's actually how we get these two numbers right here. Oh, and look, we have a float being claimed right there. There's another one. So these are all actually happening live in real time. So that's pretty cool. And that's coming from the claimed event, right? And these two numbers, floats claimed and events created, are actually coming from these two numbers right here. Okay, so we'll come back to these structs in a second. I'm not going to mention them quite yet because they're not going to make sense yet, but we're going to come back in a bit. So here's the main part of the contract, the Resource NFT. Now this fits the non-fungible token.inft and metadata views.resolver, which every single NFT on the Flow blockchain at this point, has to have both of these. Really you're required to have this one, but you should also always implement metadata views.resolver if it's NFT project, because it's up and coming. The metadata standard in the Flow ecosystem, and props to BRTech and the team for that. All right, and if you haven't already, you can watch the video on the metadata standard that I did with BRTech. I think it's actually pretty insightful. So then, the NFT has the required ID field. And what I always do in my smart contracts is I always set the ID equal to the UUID of the resource. The UUID is a unique identifier that every single resource has. I always like to set the ID equal to the UUID. I get quite frustrated when it's not, mainly because a lot of marketplaces that are kind of bad, in my opinion, like Rarible, always broadcast events and identify NFTs with the UUID. So it's hard to match them up unless you pair these two. So I always make sure to do that. There's some fields here like the date received, the description of the event the float came from, whoever created the event this float came from. And when I say came from, I mean that for example, this is a float that I have, right? So this is a float. This is the number. It's owned by me. This is the image. This is the name of it. It was actually created by me, and this is the description. But this is the float, right? This is the NFT. But if I click on it, it actually takes you to the event page. So this is the event that this float came from. So I actually got this float because I attended the Beginner Cadence Bootcamp July 2022 edition, workshop number 2. This was a Discord call we did in the Emerald City Discord, but this is the event, right? So you can see that the float got the description from the event host, what the event's ID, the event image, the event name, who originally received it, so that every float knows who originally claimed it, and its serial. Now the serial is this little number right here. That's per event, right? So this is the first one that was minted out of 40 for this workshop. Okay. Cool. And so we also have an event capability. So this is a capability that points to the float event that it came from. That way, right here in this function, you'll see it's called get event metadata. So this returns a public reference to the event that this float came from. So that we can get certain metadata about the event. Of course we have these ones, but there's some others that we could get by accessing this capability. So this is all the metadata standard get views. It supports the metadata views.display view and token identifier view, which is defined up here. So token identifier, actually, we'll come back to that in a bit. It's going to be more important later. And also, then we're resolving the views right here. And this is, again, just metadata standard stuff. So it returns a display struct that has a name, description, and thumbnail, all coming from the events that are stored inside the NFT itself. I probably should have more views here, if we're being fully honest, although I sometimes struggle with implementing views for a separate reason. But I should probably add more views here, to help the metadata standard out a little bit. But again, I guess I could do a separate video on why sometimes I don't do that. So cool. So then when we init it, I'm not going to go through all these. I guess the only cool stuff is the date received takes the current timestamp of the event. Other than that, we pass all or the current timestamp of the transaction. All these other things we just pass in. We set the event capability, the one that I was talking about right here. So this capability actually comes from right here, where you get the account of the event host and you get the public capabilities to the event. Then we, emit an event saying, the float was minted, and we increment the total supply, right? So pretty simple. Now, this is pretty cool. I don't usually see the destroy function being used a lot in Cadence, but it's actually really helpful. So the destroy function is what gets run when this resource is destroyed. So unlike the init function where this is run when it's created, this is when it's destroyed. So when it's destroyed, we actually attempt to access the public reference for the event. That way we can tell the event, actually, if we go to this event, you'll see it has a list of who currently owns it. So number 0 is currently owned by this account, which is me. Number 10 is currently owned by this account. Well, if you destroy the float, it actually updates the float home in the event to be no one. So theoretically, if I were to destroy my float, this would display nobody, right? So that's the point of this. And then it emits a destroy event right here. So then scrolling down, we get to the collection public. So this is all the things that are exposed publicly about our float collection. So all this is pretty standard. We have an owned NFTs dictionary. This is all the floats that we own. We have a deposit one. This is pretty simple. I'm not going to go too in depth into this. It's just a standard NFT deposit function. The only difference is that I'm also simultaneously tracking the certain events that this collection has. So this maps an event ID to all the floats that it contains from that event. So technically, you can have more than one float from a certain event if you claim it and then someone transfers theirs to you. So that's what we keep track of right here, and that's how when we verify that people own certain certain floats from a certain event, we actually use this dictionary right here. So we always keep this up to date when we deposit right here, and also when we withdraw right here. Okay, and at the same time, when we deposit a float to a collection, again, we try to access the public reference to the event and tell the event that it's currently owned by this new address, so that this is properly updated right here. Okay, that's pretty simple. We emit deposit. In withdraw, it's pretty similar. We take out the NFT, we remove it from this dictionary right here. So that we know we no longer own it. And then we also attempt to access, the public event. And so one interesting thing about floats is that some of them are soulbound. So if I scroll up here, you'll notice that it says allow transfers. So when I actually created this event, I made it so that you can't transfer it. That's why there's a button that says, I can allow it. I made these floats soulbound. So what soulbound means is you can't transfer these floats. So you'll see right here that if we're able to access the public reference to the event, we actually assert right here, is it transferable? And if it's not transferable, then we panic and say this float is not transferable. So the event host can actually make soulbound floats. So if we go to create an event, you can see right here that you can make it a soulbound option. And if it's soulbound, then you can't withdraw it, right? Otherwise, we return the NFT, okay? Now, this one is just to delete the float. So if you want to delete the float, you can always do that. That's pretty self-explanatory. This just gets all the IDs of all the floats you have so these just get all the IDs you have right here. This one gets all the IDs specifically from the ones that we can access the public reference to the event from, just a utility. This gets all the IDs or all the float IDs from a certain event. So we can verify a user has a certain float from a certain event. This just borrows the NFT. This borrows the whole float, so we can call some functions on it. And this borrows the view resolver for the metadata standard. So pretty simple in terms of the collection. Now, this is where things get pretty complicated when we start talking about the event. So the reason that this gets complicated is because if you look here, there's actually a lot of options for how you can leverage certain restrictions on your event. Now, usually this would be done off chain in some database somewhere. However, and then you would provide some admin signature on chain. But in the sake of everything being transparent on the blockchain, we or I made this all on chain. So all these verifiers are actually in the smart contract, and I'll show you where. So we have this thing called an I verifier. It's a struct interface. And this is something that each verifier, so a verifier is a limited quantity or a time limit or a secret code or a minimum balance. Those are 4 types of verifiers. And, each of those has to implement an I verifier. So if we go to the float verifiers contract over here, you'll see there's actually a ton of them, right? There's a time lock, which is this one right here, the time limit. There's a secret, which is, the secret code. There's the limited, which is, the limited floats, right? Limited quantity. And then there's a multiple secret, which we kind of put aside for now. There's a better secret, which we now use secret v2 because secret is not very secure. And a minimum balance. So minimum balance is this one right here, okay? So each of these you'll see implements float.I verifier. So that inside of our event, let's scroll all the way back down here. Oh, this might be a little annoying to scroll back and forth. Let me actually maybe open this in a new tab. So when that way down here, inside our float event resource, so this is a resource that is for the a certain float event, you can see we actually store a dictionary of verifiers. So if this event, for example, had a minimum balance and a time restriction, it would have an array of I verifiers, okay? I verifiers, right? So I verifiers are, again, a way for us to abstract away, these different restrictions so that we can store them all in one dictionary, right? So this stores anything that is an I verifier. And that way, if you wanted to, technically, you could pass in your own off platform, right? And make your own if you wanted to, which is pretty cool. So, we'll talk about verifiers in a second here, but to continue on, so this is just a public reference to a float event. So it just gives you all the information about it and, all the functions that you would want to call in order to get certain information about it. Like, for example, what groups does it belong to? What are the verifiers it has? Who are the current holders? Claiming it's public, right? You can always claim a float, only if it's available, right? So those are all just public stuff. Now we have this public resource float event, right? And so this is the actual event of, this is the float, what represents a float event, right? So this is whether or not it's claimable. So, a user can, if we go back to one of my events, let's go back to my event right here. I can actually turn off claiming if I wanted to. So I could click this and pause claiming if I wanted to. That's always an option. So you can actually turn that off by toggling this. This is a list of people who have claimed it. This is a list of people who currently hold it. So these only include the initial claimers, whereas this includes the current holders. This is the data was created, the description, the event ID, some extra metadata if you have it, what groups it belongs to, who created it, the image, the name, the total supply, how many were minted from this event, whether or not it's transferable, a URL. So you can, if you click at the top here, this actually takes you to a URL that the person can configure. And a list of verifiers, right? So those are all the things you can do. You can also, here's a function to toggle whether it's claimable, toggle whether it's transferable. So both of these functions are right here. So to toggle claiming or toggle transferring, right? This is for updating metadata if you want to. I don't know why you would do that, but you could do that if you wanted to. This is the function that we were seeing earlier called update float home. This is the function that if you would deposit or withdraw from your collection, it will update who currently owns it so that this list gets updated right here. And for the record, you can also always download a list of claimers by clicking this one right here, and it'll give you a CSV file that you can actually open up in wherever, and you'll be able to see a list of people. So that's pretty cool as well. All right. So going back here, you can add this to a group if you want to. So I can add this event to a group right here. So I could add this to town halls. I'm not going to do that, but you can see it already belongs to Emerald Academy right here. So if I click on Emerald Academy, it takes me to the Emerald Academy group, which is pretty cool, right? So these are all the events that happened from Emerald Academy. All right. I can remove it from a group, right? Which is, right here. So I can remove it from a group if I wanted to, which is, whatever. See if someone's claimed it, right? And if it has claimed, you'll see it returns token identifier. Now that's the struct we were looking at before, where token identifier is just the ID of the float, who owns it, and the serial. So it's just a wrapper around certain data. So there's that. There's some other helpers here, like who currently holds it, if someone, who claimed it, who currently holds it, getting metadata, getting the list of verifiers, getting what groups it's in, getting the metadata standard views, getting the prices of the floats. So you can see there's a token info right here. Now, token info, again, if we scroll up, is a path and a price. So we use the public path to say, okay, you can pass in whatever token you want. If you want to make the price float token, you can pass in float token, float token, float token receiver, or at a certain price. But if you want to pass in FUSD, you can pass in the path to FUSD and the price for that one. Or in the future, Emerald token, which the whole platform will be converted to Emerald token eventually, will have a path and a price for that. So it's just a way that you can actually pass in any token you want, theoretically, right? So it's pretty cool. Although the platform itself only supports float token as of now. Okay. So we have that, and let's see here. So what else was I on? Oh, so then there's a function to batch mint. So if you want to, right here, you can actually award manually to many. So you can actually upload a CSV file and distribute a bunch of floats to people, and that calls this function right here, batch mint. So it takes in a recipients, which is a bunch of collections, and gives it to all of them, but it automatically checks to see if that person already has one, so it doesn't give it again. Now, this is where the hefty stuff happens, so mint and verify mint. So you can see there's actually quite a lot going on here. But minting is basically a function you call if you want to just claim a float. So every time you go to an event and you claim a float, you're actually calling this mint function. So you'll see it takes in a recipient. It makes sure you haven't already claimed it or else it panics. It basically makes a new float right here, passes in all the information about the event. It marks that you've claimed it. It marks that you currently hold it, and it updates the total supply, which is pretty awesome, right? So that's what happens right there, right? Which is pretty awesome. And then it deposits, the event right here, right? So pretty standard stuff, okay? And also this total supply is not for like the whole contract. It might be confusing. This is for the certain event, right? So how much each event currently has, and then then it deposits the float to the collection. So pretty simple stuff, right? That's just minting it right there. So yeah, okay, and then we get to verify and mint. So verify and mint is basically like if there are verifiers on. Actually, we can even look it up. So if we call verify and mint, let's go down a bit. Where is it? Oh wait. So then where is? Wait, hold on one sec. Let me search just to make sure that I'm doing this correctly. Okay, yeah. So sorry. So yeah, what's happening actually is when you're. So I actually misspoke. When you're claiming the float, you're actually calling this claim function. So if we scroll up a bit, yeah, I messed up a little bit. But if you scroll up a bit, you can see that the mint function actually isn't available publicly. Only the claim function is. So when you actually go to claim a float, you're calling the claim function. So let's go to claim for a second. Claim. Here's claim. So when you're the user and you go to click on like claim a float, you're calling this function. So you pass in your your collection right here and a params, right? So this is basically like the certain params you would pass in. For example, a secret code. So when you like type in a secret code, that gets passed in right here. It gets the prices to say, hey, if make sure the prices are none, because if there are prices, you're supposed to call the purchase function. Make sure you haven't claimed it, and also make sure that the event is currently claimable. So if the event turns off claiming, then they can't call this, right? And then they call it self-verify and mint. Now verify and mint is up here, and that's what actually makes sure that you go through all the verifiers. So right here it says for each identifier in self.verifiers, get the verifier itself, right? You get the verifier right here, and then you call verifier.verify. Now, .verify, you'll see, is on each one of these verifiers. So in the secret, in the time lock, there's also a verify, and each one of these verifiers goes through a bunch of assert statements. So for example, make sure that the get current blocked at timestamp is greater than the start date than that you were supposed to mark, right? And also make sure that the event is currently like lower than the ending date, right? So it's a way to go through all the requirements and make sure that you're fitting all of them. And similarly for a secret code, get the secret code and do public key to verify. So it's a bunch of like weird like signature stuff, but it's basically like when you go to claim a float, you type in a code, it like hashes it, right, and then it or encrypts it. Sorry, it passes it on chain and then tries to make sure that the encrypted value is equal to what's stored here, right? So pretty cool. I could make a whole separate video on that process, but it's probably not worth mentioning in this video. And then yeah, so then it sets the secret code right here, or it checks the secret code right here. Okay, so it's looping through all the verifiers, making sure each verifier passes, and then it continues going on and going on and going on. And if it makes it through this whole while loop, then each verifier didn't panic in the assert statements and made it through totally fine. Okay. So that's the verifiers. So if we make it to the verifiers, then you're good to go. You can mint it, and then you can emit the claim event, which is what you're seeing on the front page. When everyone goes to claim the float, you're seeing that on this front page right here. You can see one right there. All right, cool. So when I was talking about the mint function before, this is when you manually mint to a certain user. So this is only used by the event owner. So the event owner would go in here and award manually to one person, and they can call this mint function because this mint function, bypasses all the verifiers. So I can actually, as the event owner, mint it to somebody, and they don't have to, have any of the verifiers ready, right? Which is why the preconditions are less for this one. Okay, so then there's the purchase function. This is pretty similar. The only difference is that there's a royalty, there's the Emerald City Treasury address, it gets the payment type by the identifier, and the token info. So that's all through the token info struct I showed you earlier. And then the event host vault. So we make sure to pay the event host, but there's a 5% royalty to the Emerald City Treasury as well. So that's what we're doing right here. We're depositing to the Emerald City Vault right here. So this is the Emerald City cut. We deposit to the Emerald City Vault, and then we also deposit to the event host vault right here, right? And then you call the verify mint function, and we already covered that as well. So that's for the float event. Then we have, this resource group right here. This is just for float groups, so like the ID, the name, the image, and description of the group. So if we go to Emerald Academy, for example, this is a group, right? So it has a name, a description, and images and stuff like that. So that's all stored right here. Here is the float events, collection. So this is a collection of float events. So that's what actually you're seeing right here on the events tab. that's right here, right? So that's all the events you store. So obviously we store a bunch of events, we store a bunch of groups. You can create an event, right, with certain verifiers. This is pretty self-explanatory. You're just creating an event with all the requirements, like all the name, the image, the description, the verifiers, the extra metadata, and the initial groups it belongs to. You can delete an event. That's pretty simple. It just, will remove the event from the dictionary, and also make sure to remove, the event from all the groups, so that if you delete an event, it also gets removed from all the groups that it was in. You can create a new group. You can delete a group, and if you delete a group, and make sure to remove that group from all the events, so that the event doesn't think it belongs to a deleted group. You can add an event to a group. So again, same thing, but the other way, and remove an event from a group as well. So this stuff is pretty simple. If you know what it's doing, you can look it over. So the last major concept of this contract, I know this is getting kind of long, but the last major concept of this one is a borrow shared ref. So inside your float events collection, you can actually call this thing called borrow shared ref, where if you actually on the float platform, under account, there's this thing called shared minting, where you can mint for other people. So if you belong to a company, for example, you can add people to your list, and then all those people can also create events and toggle claimable and transferable for you. And that's handled by this borrow shared ref one, where you can go into someone else's collection and call borrow shared ref, but it only works if you are allowed, which is this assert statement right here. And you're allowed if someone grants you access, which is in the grant account access contract. So every account stores a info, which has an allowed dictionary, and this is full of people that you allow to access your float events. So again, inside this float contract, if we scroll all the way down here, to where that was, it's quite long, actually. Holy cow. But if we scroll all the way down to borrow shared ref, you can see you're only allowed to borrow it if you are currently allowed. So if self.owner.address is currently allowed in shared info, right? So that's pretty cool. And then with that, you get a reference to float events. So with a reference to float events, you can delete events, you can create events, you can do whatever you want, right? That's pretty cool. This allows you to help her to get all the events. This is just a metadata view resolver, and then that's it. So that's the end of the contract. I hope that was helpful for all of you. The only other thing I will note is the float incinerator contract. So this is actually something that I really like. On the Incinerator page, you can actually go ahead. Oh, look at that. The flame strength is already up to 20,000, and that's quite a lot of floats incinerated. But you can actually go here and incinerate floats if you don't want them, and it will burn them in the fire. And so that's actually coming from the float incinerator contract, where every account has an incinerator in their account storage, and you can go in, you can burn floats. You pass in a reference to your collection and the IDs you want to burn. It burns them all, increases your flame score, increases the float incinerator flame score, and is a pretty cool way for the community just to burn some floats. So, and then this is a function called calculate score, where we actually the flame strength is all calculated through these calculations right here. So when you burn a float, the longer you've had it and the lower the serial, the higher the score, right? So you can actually take a look where if the serial is less than 10, it's a high score. If the serial is less than 100,000, it's much lower. And same thing with the time difference. If the difference that you've burned and received it is really high, a year, then it's 5. If it's a month, then it's this one, a week, a day, an hour, until it's down to 0. So I hope this was helpful. And if you have any questions, as always, reach out in the Emerald City Discord, and I'll see you later. So bye-bye.